Okay, in this module, let's look at the simple interest and compounding interest. So before we start the calculations, let's introduce some of the corresponding symbols. So here in this case, the cap P represents the amount of principal that is invested at the beginning of the investment period. For example, you can replace capped P with $1,000 or $1 million. Capped N here represents the number of measurement periods for which the investment is being made, right? So the capped N usually will be, say, the number of years in the investment period, right? So if you plan to invest for 10 years, then N is 10 years, N equals to 10. And lower R here is the nominal rate of interest per measurement period, because the measurement period usually is, let's say we use years. So here the lower R is the rate you will quote for so-called annual rate, right? So if there is a particular loan, the interest is measured at, say, 5% per year. That's what the R represents. And the lower I here is the effective rate of interest per measurement period. And the I and R can be the same if there's only one kind of conversion period in each measurement period, right? So if you only calculate the interest once a year, which is for a lot of saving products, then these two are the same. But if you have multiple so-called conversion periods, which is represented by lower m here, then I and R will be a little bit different. So that's why we need to create two different symbols for effective and nominal rates of interest. And very lastly here, m, lower m, is the number of interest conversion periods per measurement period. So here, depending on really on the case, say if there's a product that we calculate interest each month, then within 1 year, which is a measurement period, there are 12 interest conversion periods. And if the interest is calculated daily, then in a typical year, then we will have 365 interest conversion periods. So that's what these variables and corresponding symbols mean in the following two slides. The first, let's look at the simple interest calculation. So the simple interest, I think, is very simple as its name suggests. So interest is only paid on the original kind of the principal, original kind of capital. Right? So if we use example, I think I would better explain this simple interest or this concept. Let's suppose you're investing $1,000 on the product, and which promise to pay you 10% interest per year. So if it's simple interest case, then every year you will receive 10% of your initial capital, which here is $1,000. So every year you will receive $100 as interest. But what will happen in the second, third, and to the last period is that every year the interest is only calculated on the initial capital, right? Not on the accumulated kind of amount of capital you made over the years. Right? So if you invest in n years, by the end of year n, the total amount of capital you will have is simply P times 1 plus N times R. Here N is 10 years. R, remember, is the nominal rate, 10%, and P is $1,000. So 10 years later, the total amount of interest you made is $1,000, and the total amount of capital you will have is the interest, which is $1,000 plus initial capital, which is $1,000, so you will have $2,000. The total return is $1,000. So this is a case of simple interest. And normally in real life, we have compounding interest. Most of the investment and also some of the loan products we're thinking of, their interest is kind of calculated in the compound approach. So compound will mean is that interest earned will be automatically reinvested. Right? So rather than you set aside your interest, what you would do is that you put the interest along with the initial principal, and you reinvest the total amount in the following year. So let's still use that the case of investing $1,000 and each year receive 10% of return. So by the end of first period, what you will have is $1,000 times 1 plus 0.1. So you will have $1,100 in total. Then the next year, the second year, you will invest $1,100 in total into this investment product, which promised you pay 10% interest rate. So by the year of second year, and by the end of second year, the total amount of capital you will have is, it's $1,100 times 1 plus 0.1. So it will become $1,210. right? So you can calculate in using this kind of equation here. P1000 R is 0.1, right? So 1 plus 0.1 is 1.1, and square of that is 1.21. So the total will be $1,210. So you do that for the rest of the years. By the end of the end period, the total amount of money you will have, it will become P times 1 plus R to the power of N. Right? So this will be much higher than the case of simple interest. Right? So that's why I think we prefer compound interest, and that's the power of compound interest. So in this module, very quick review, we introduce and compare the difference between simple interest and compound interest.